I'm Nishant, and I'm work for the UAM sub project at NASA Ames. I would like to introduce Adam Monsalve and Robert Segers. They will be talking about identity and access management.
Thanks so much, Nishant. I appreciate that introduction. As he said, I'm Adam Monsalve. I'm from CNA, which is a nonprofit in the DC area, supporting a number of federal government organizations. And Rob, you want to introduce yourself?
Yes, thank you, everyone. I'm Rob Segers. I work for the FAA, and I'm in NextGen, and I'm the Information System Security Architect for the National Airspace System.
Excellent. Thanks, Rob. So I think we'll just jump right into it. So Rob and I are focusing on the topic of identity and access management today. So we're hoping to sort of give some fundamentals. So what is IAM? Why does it matter in the realm of cybersecurity? And then why should we be thinking about IAM specifically in the context of urban air mobility? Then we're going to look into a couple topics that relate very much to IAM on the international front and the topic of trust. And then there's a sort of an overarching question we'd like to discuss related to IAM and related to identity generally about whether a federated or centralized architecture is the most appropriate for UAM. I believe we were going to have a poll actually around this this topic. I'm not sure if that's on the conferences.io or something, but we'll talk about that, and if there's any poll results, we can discuss those as well. Okay, I think we can go to the next slide. Okay, so what is identity and access management? So sort of the textbook definition here is it's a security discipline that ensures that the right people or the right entities have access to the right resources at the right times. And I do think while the term IAM may not be completely familiar to those of us not in the sort of cybersecurity world, I think most people have interface with IAM on an everyday basis in most cases. Whether it's logging into your email or logging into your favorite social media account to your work computer, doing all of those things, you're interfacing with an IAM capability. And so I'll sort of step through the three main facets of IAM and sort of try and draw why they're important and how maybe an example of what you see. So the first is identification. So it's important for when you log into something for that system to identify you to differentiate you from any other individual. And like the example I might give is when you log into your work computer, if you're for say in a role like an analyst like myself, you wouldn't expect to have access to the same information that the HR department has. So when you log into that network, you provide your credentials. The first thing it does is says, okay, this is this person, and I know that they have access to these and those things. So the first step is this person. So I know I can identify this user apart from another user. The second key fundamental aspect of IAM is actual authentication. So sure, I have presented a username, for example, to identify myself. However, it must be verified that I actually am the entity or the person associated with that username. So how is that verified? That's usually done with a password. Something along the lines. There are different mechanisms for that. Maybe you have an authenticator app set up, and when you put in your password, it prompts you to enter a PIN or something like that, or something that you have like an RSA token to further verify that you yourself are actually authenticating in this transaction. So that's sort of the second key piece of IAM. And then the third piece, once you've been verified as a specific user and you've authenticated yourself, is the authorization. So now I know who you are. What are you actually allowed? What do you have the permission structure to see within this organization, this resource whatsoever? One thing that I would sort of, so hearing some of the talks earlier, I think Ken and maybe Gano had mentioned things like least privilege and zero trust. And those things are very key. And IAM is a key enabler of those things. So least privilege is the idea that you should only have access to the things that you need to perform your job. So like if I go back to my previous example, as an analyst, I don't need access to other people's personnel records to do my job. I just need access to maybe some databases or some tools, analytic tools or things like that. Whereas the HR personnel needs access to actual personnel records. And by sort of segmenting your access so that you only have access to what you need to know is a core security principle, which in effect makes a compromised account less useful for if a malicious attacker is able to do that. So what we want to do, and going back to the zero trust concept, is we basically want to assume that a network is compromised. And what actions would we take to make that the network compromiser to make their life more difficult? So least privilege is one fundamental concept that aligns with that very well. I will add one more thing, is that my example was very centered on users, so a person interfacing with a system or an organization or so forth. That it is important to remember that IAM applies both to persons and to non-person entities, so applications, server systems, which is a very relevant tie-in to UAM, which has a whole host of different types of entities that are going to be important to enabling the system. IAM applies to all of them, and we need to make sure that we consider it for each and every entity within the ecosystem. Anything to add to that, Rob?
You covered this really well, and I would say as a fundamental piece of zero trust, it's really important because the first check that a zero trust microsegmentation system would do is obviously use the identity. But then I would say the added value of zero trust is that you're also using the observable state of the user or the system, which is over top of the identity. So you may have compromised the system, you may have taken a hold of the identity, and in zero trust, you're then using additional signals to further try to limit the lateral movement of an intruder.
Excellent. Yeah, that's a great point. Yeah, zero trust has many layers to it for sure, but I think that's an important one to note. Okay, I think we can go to the next slide. Excellent, thank you. So now that we have a sort of general understanding of what is IAM, then the question is why do we need to think about IAM in the context of UAM? So I bring up this notional architecture from the UAM ConOps as a way not to focus in on any specific piece of the puzzle here, but to identify all of the different actors and systems at play here. We have the PSUs, we have USSs from the UTM ecosystem, we have SDSPs, we have the DSS sort of underpinning a lot of these communications, all these systems that are talking to one another, and then the FIMS and the FAA side as well. And then we have a whole number of users that are identified in the system. So we have UAM operators, we have aircraft operators, we have the general public, we have public safety personnel. All of these entities and people involved in the ecosystem need to have the appropriate IAM applied when they actually do interact with it. And you could imagine, for example, when interfacing with the DSS, it might be necessary for a vertiport operator to do certain things and a PSU to do different things. And you could imagine those sorts of nuances with any sort of exchange between two entities when interfacing with when multiple entities are interfacing with one central entity. We need to make sure that the appropriate IAM requirements are in place. And I'll sort of just take a step back and thinking about the need for IAM and what is it actually protecting. And you can kind of look at this diagram and see three sort of buckets of organizations. We have government organizations here, we have commercial organizations, and then we have public safety organizations. And you can imagine each of those might have different concerns when participating in UAM. Maybe government organizations are concerned with national security concerns, and they want to make sure that any threats are mitigated as appropriately. Maybe the public, the general public who are interfacing with this have privacy concerns. They have their data integrated into the system, and they're seeing on the news all the time all of these data breaches, and they're concerned with this new ecosystem that's highly digitized. Does that make it more susceptible to data breaches, and is their data at risk? And then the commercial entities will have proprietary concerns. They have business practices. They have boards to meet, and they need to make sure that their bottom line is protected, so that their proprietary data is secure when interfacing with the ecosystem. So those sorts of general concerns across the ecosystem are important to consider, and IAM will help to ensure that the appropriate protections are applied to help alleviate those concerns. Anything to add there, Rob?
Yes, I would like to point out that the fundamental protection of information being transitive across different organizations is really important, and ensuring that interoperability. So how does, organization A know that the information they receive from organization B is sufficiently protected through IAM and also through the overarching information security protections that organization applies, so that the information is in fact fit for purpose for their operations? Because information may be based on the risk appetite being protected at one level by one organization, while the other organization needs it for a specific safety level operation. And so IAM is at the foundation of that, and the IAL, the information assurance level, and the level of assurance in terms of the handling of the identities is fundamental then, and that interoperability to assure that integrity, confidentiality, and availability of the information.
That's a great point. Thank you, Rob. I 100% agree. Okay, I think we can move on to the next slide. Excellent. So
sorry,
go ahead, Rob. No,
Adam,
go ahead.
I'm going to take that one because this is one that's dear at my heart.
Oh, of course.
The International Aviation Trust Framework is kind of a concept that was developed through ICAO and the Trust Framework study group, which is now turning into an official ICAO panel. And it's a combination of an identity federation concept to create interoperable identities, but also interoperable protections of information exchanges using those identities. And obviously, when you look at the airspace system at a global level, it spans every facet of aviation, from airline, aircraft, the air navigation service provider, to sometimes even the fuel supplier or the caterer that brings meals on board of the aircraft. So if every operational interaction that has to do with, I would say, gate to gate, and including fabrication of an aircraft into operations is touched by this trust framework. So if you can go to the next slide. So today ICAO is already a trust framework, but it's a paper-based trust framework. So the 193 countries that are members of it develop standards, and they apply those standards to member states. Member states then codify those into regulation, and regulation gets used by both the aircraft manufacturers and by the operators to secure and to provide the safety that is needed for aviation. In a connected world where we have cyber threats and we have to have a more in-depth assurance level, both for identities and information, you have to go a step further than what I would call the paper-based trust framework. You have to get to an operational trust framework that assures the interoperability of information protection through compatibility of identities. And so as part of that IETF, you have to have the appropriate legal agreements between the participants in the trust framework. You also have to have a set of technical requirements that are agreed upon. So to give you an example, in the previous talk, we talked a lot about the modeling of the threats, and then the type of protections that you have to apply. So within ICAO, we've developed a set of performance requirements for confidentiality, integrity, and availability that were based on ISO 27001 and NIST 800-53, but that are performance based, and that's for the information exchange. Then for the identity, we basically developed a common policy that can be applied so that participants in the trust framework can have the confidence that the information is protected at a certain level, so that they know whether that is compatible with the risk, with the safety risk that they could incur when using that information. From an operational perspective, we believe that the trust framework needs to provide an identity federation where basically there is a trust anchor at the ICAO level that allows operational trust path to be determined between entities that independently participate in the trust framework, but have their own identity systems. And then one of the more important aspects, of course, is trust but verify, which is the auditing component. And there we envision that industry-based auditing, such as ISO auditing and web trust auditing for identity, can then provide independent attestation of the adherence to the technical requirements, so that participants in the trust framework can have the confidence that the information that they do receive is sufficiently protected and is coming from the source that it says it is, because that's what it comes down to. So that's kind of the IETF. And Adam, anything you want to add there?
No, I wouldn't. I don't think I would ever dare to add anything to what you would say, but I would I would ask a question. So one thing to clarify for those that aren't maybe as familiar with some concepts is the idea of an identity federation. So you stated that at its core, one component of the IATF is this identity federation. Can you maybe explain a little more what that means? Is there an example that folks might be more familiar with?
So I'll take a very simple example. Well, it sounds simple, but it's probably not. Let's take datacom, right? Everyone is probably familiar with the datacom that we have today, where you have an aircraft from any nation flying to another nation, and the air navigation service provider wishes to connect to the aircraft. And there's two use cases. One time the aircraft connects to the NSP and vice versa. But the aircraft is from one state, which basically has its own identity federation or identity system, and the air navigation service provider is from another nation. Now, if we want to protect that information, either the integrity or the confidentiality, people are very familiar with setting up, say, a TLS or a DTLS tunnel between two entities. But in order to do that, you have to exchange or perform mutual authentication. That mutual authentication means the exchange of digital identities. Well, how does that aircraft know that they can trust that digital identity from the air navigation service provider from another nation? And that's where the federation comes in. So if both participants are part of the federation, then they can establish a trust path, which is something that's familiar within the public key infrastructure to perform that mutual authentication.
That's helpful. Thank you, Rob. No, and I think the idea of the role of ICAO, which everyone in aviation is familiar with, as serving as that sort of root of trust for everyone across aviation, both in crewed aviation and extending to these new UAM and AAM ecosystems, seems like a very reasonable approach. So I think you're onto something there, Rob.
Yeah, one of the key things that's important is when you do create a federation, you have to have a number of architectural principles of how you create that trust. And one of the things that we've learned through our own US federal bridge is that you want to ensure that you adhere to a very clean tree structure. It doesn't mean that there's a single route, but you have to have trust relationship, maybe to either trust list or a bridge that always go up to a pinnacle. Because one of the challenges is if you allow then additional horizontal trust relationships, you create what I would call the ball of yarn, which is something that we are very familiar with our US federal bridge.
And for those unfamiliar, the federal bridge is basically this overarching U.S. system. If you have a PIV card or a CAT card, it's issuing your certificates that link your identity to that PIV card, for example. And it's the U.S. sort of national system underpinning all of those types of things. Is that right, Rob?
That is correct.
Okay.
And to give you the one of the reasons why it became a little bit opaque was because when there was a federation, it was so popular to be able to participate in the federation that everyone wanted to be part of it, whether they should or not. So it became a victim of its own success.
Absolutely. Yeah, we don't want to repeat the mistakes of that system. Okay. Well, I don't think I have anything to add here, Rob. Should we move to the next slide?
Yes, please.
Okay.
I think we have a delay in the sharing.
Yeah, are we having a frozen screen again, or there we go. I'll just hit these quickly, Rob, and then we can kind of go back
Please
and forth
go ahead.
as we go into the next. So I think we talked about these topics already, so I'll be brief. But basically, we wanted to, now that we've talked about UAM and IAM in UAM, we wanted to sort of give some specific examples of where threats may be mitigated by IAM capabilities. So this is not meant to be an exhaustive list of these threats, but just to give you some tangible examples of the value here. We thought we'd show 3. So we have spoofing, data leakage, and denial of service. And I think these have all been defined in previous presenters, so I won't go into the details there. And we'll have a slide on each of these subsequently, so we can move to the next slide and we'll start with spoofing. Okay, so I'll take the first example and then I'll hand it over to you, Rob, and you can maybe give some more scary examples. So I'll start with a simpler sort of competitive version of this threat, where in an identity in a federation, in a federated ecosystem such as AAM and UAM, the idea that it may be possible for a participant to give itself an advantage is entirely possible. And the ability to potentially spoof one aspect of the ecosystem, you could, for example, imagine the spoofing of a PSU or the spoofing of a vertiport operator or something of that nature. And if you did it in such a way that that it wasn't overly obvious, you could just slightly nudge things in the direction of your own company and therefore benefit yourself, and you could reap the sort of financial benefits that may come of that. You could be detrimentally disruptive to your competitors, and so there's probably a number of ways that can be borne out. And so IAM and sort of strong IAM principles ingrained and sort of baked in, as the previous speaker was referencing, will be critical to preventing such things like spoofing. And if we have protections on each of these systems, so that, for example, when you interface with a PSU or you interface with the DSS, that there's strong authentication protections and strong authorization mechanisms such as OAuth and some like industry best practices in place, it really makes spoofing much more challenging and prevents this sort of proprietary benefit from being enacted. So I'll pivot to you, Rob, and I'll let you talk about some other options here.
So imagine, and I'm coming always from an FAA perspective, from an airspace use perspective. Imagine that you had the ability to spoof a UAM or UAS, and you spoof it with an identity that is perfectly, authorized to fly in a certain area, and that way you can basically act like they are that organization, but in the same time you have a malicious intent, and by being allowed to fly there, you may be able to execute your malicious intent, whatever that malicious intent may be, kinetic attack or any other type of attack. And law enforcement in general can only react if they can tell the good guy from the bad guy. And spoofing basically delays that ability to tell the difference between good and bad, because if it shows up as good and authorized, then it may take longer for them to be able to react. And that's I think, from a protection concern, probably one of the larger ones. If I may come back to Adam's example, if a competitor would spoof a lot of use of airspace of an airspace that is typically being used by a competitor, then they may deny that competitor actually from being able to effectively use that airspace that they normally would want, which could have competitive effects.
Absolutely, Rob. Yeah, I think these are all very reasonable scenarios we're laying out, and I think IAM is important in helping to prevent them. Okay, I think we can go to the next slide with data leakage. So I think I mentioned this briefly earlier, and I'll be brief, and I'll pivot to Rob to expand a bit, but there will be a lot of sensitive information in the UAM ecosystem and in AAM, due to just sort of the operational nature, the types of operations, the number of sort of the general public's involvement. Just by its nature, there will be like I said previously, privacy, proprietary, and sensitive data. And we need to be very vigilant in applying least privilege so that actors within the system only are able to access and change, for example, data that they should be allowed to change. And the more we understand the roles of the entities, the people involved with UAM, the more we know what they do and do not need, the better we can help to tightly restrict access and overall improve the security posture of the overall ecosystem. Rob, do you have some thoughts on
Well,
this one?
I can tell you that a successful attack is always preceded by gathering of information. And so if you can probe someone else's system and get sufficient information out that you shouldn't get out, since they may not have applied the rule of least privilege, then the next thing they will do is use that information to set up the attack. What can I say more?
Yeah, I think you put it well. Okay, and I think we can go to the final threat, denial of service. Rob, I'll hand this one over to you. Let you talk through this.
Yeah, the denial of service is a bit of a mixed bag, right? Because IAM by itself can lead to what I would call additional work to be able to authenticate information, which by itself, you have to be careful not to open yourself up for DOS, because if your amount of work that you have to do to actually reject a message is more than it takes for an attacker to send it to you, then the attacker may be able to sufficiently send you false messages that you have to triage before you can get to the good messages, and it may overwhelm you. So the rule of the road is use your standard practices around DOS first, and then make sure that you have a very performant and efficient way to do your authentication, so that the useful messages that make it to that filter can be appropriately authenticated.
Yeah, absolutely. And I know denial of service is always top of mind as UAM will be a component of critical infrastructure. Denial of service will have major impacts as it operationalizes and matures. So thinking about this is certainly really important.
And there's other methodologies that could be applied if you find yourself under a denial of service attack. Make sure that you can pivot your connectivity in such a way that you're basically creating a side channel so that the attacker doesn't gets completely cut off, and you can have your useful information going through that alternate channel.
Absolutely. Yeah, I think some other folks on the earlier sessions have touched on similar types of topics, and I think that's a great point. Okay, I think we can go. We have one more slide that sort of hits this major topic we wanted to bring up, and I'll sort of tee it up for you, Rob, and I'll let you discuss this. But basically, we've been talking about IAM, and there's sort of this general approach that needs to be considered in how are we managing identities sort of broadly across the ecosystem. You could imagine, for example, a single entity, maybe it's the ANSP, maybe it's an industry entity that manages all identities, and that it ensures that sort of centrally that IAM is managed in the same way uniformly across the ecosystem. Whereas you may also have this federated identity construct, which I think Rob touched on a bit earlier, where you segment the management identities within sort of groupings, regions of the ecosystem, and that each sort of region is responsible for its own identity management. And there's sort of probably pros and cons to each of these. And I think things like the IATF lend themselves very well to this federated approach. But I know you have thoughts on this topic, Robin. I'll just sort of leave it there and let you talk further.
So my philosophy is it's not one size fits all. So what you really need to do is to have a federation of centralized identity management. And the level of centralization is really left onto the user community. But always realize that even if you create a very successful centralized user community, at some point in time, you will have to go with your identities outside that community, and you end up federating your centralized identity system with others. And by using a clean tree structure, like I touched on before, you're basically able to manage your scope of trust. And so if you think about this as a multi-level tree, depending on which branch you put your trust anchor in your identity community, you can basically have a de facto limitation of which identities you accept within that community. And as you move up in the tree in your federation, your trust becomes broader and broader. And that way you can basically, based on the type of use case, change your the scope of trust and manage that scope of trust. One thing I wanted to touch on is we talk a lot about trust, and I don't want people to confuse societal trust with what I would call technical trust or confidence. In all the cases so far that when we talked about trust, we're really talking about confidence and what I also sometimes term as technical trust, based on a set of agreed requirements. When it comes down to societal trust, it's always up to the relying party and the implementer that needs to determine at what level they want to trust another entity. And but as you can see, by using the tree approach and by recognizing different points of trust within that tree, you can get the best of both worlds.
Yeah, absolutely. I think that's a nice way of putting it. I'm not sure how much time we have. I do see a question in the chat that I'm not sure that I fully have the ability to answer this, but I'll throw it to you, Rob. From Alex, he says, "What about a fully decentralized identity based on protocols instead of entities?"
So a protocol still requires any protocol that I know of, at least in the internet, proves the possession of a secret. And I know one of the previous speakers said we need to limit the amount of secrets in the system. The reality is we need to limit the amount of secrets that can leak out, because one of the fundamental things of IAM is that I have a secret, which is a private key, and that private key proves that I'm in possession of that private key, and you can trust that I am who I am. The problem with that statement is that there has to be an independent attestation that I am who I am in relationship to that private key. And protocols use those private keys to be able to identify people or systems. But without that attestation and your identity federation, anyone can take out, I can do a simple command of OpenSSL and create myself a self-signed private key and public key. and I can sign something to a protocol. I can set up a TLS connection, but you have no guarantee whether I am who I am or whether I'm a man in the middle that is trying to, do some nefarious action. And that's the problem with saying I can do this just with protocols.
Yeah, I think I agree that independent party to be able to say, because technologically we can sort of create these cryptographic things all day long, but the ability to then associate those things with an actual person, that's where it gets tricky. I agree with that. I have some other questions, but I guess should we look at I see there's a couple. I don't know, Terrence, if I'm stealing your job, but I could just pose some of these questions to Rob that are in the conference.io.
You can go for it. Yeah, I was about
Okay.
to come on and say it. Yeah.
Okay. Yeah. Okay. So first, I'll say. So one question is, how do you maintain trust in the federated IAM when different nations may have different levels of trust between them?
This is the difference between societal trust and confidence. So say that a unfriendly nation state is a participant in my trust framework. And by all means, they have met all the requirements on the audit. And I know that they have a mature information security protections, and they have mature identity and access management, and I know that they are who they are. Well, from a societal trust perspective, that's perfect, because now I know at least that they are my unfriendly nation that is trying to communicate with me. Then my political and societal trust rules may say, hell no, I don't want to accept your information because I know who you are, for sure. And therefore, I actually filter it out, or I give you less privileges. And that's the difference between societal trust and confidence.
Makes
Sorry,
sense. Makes sense.
sorry for the phone call in the background.
Oh, I didn't hear it at all. So I think the last question we have is, how do you separate the data from the service provision? Currently, data belongs to a service provider. How do you break this?
So service providers by themselves have to be part of your trust framework, which means that service providers always still depend of information that they collect. They may have a value added function, and then they distribute it, or they may be a communication service provider. They need to follow the same rules as the producers and the consumers and the operators in the system. So it's not because they are a service provider that they can work outside the system. So they're an integral part. And as a result of, so one of the rules that we developed under ICAO was that it's not about the provider, but it's about the assessment of the assets and systems that operate on the data or information that are being transacted. And so if they have a certain set of systems that are in scope for an end-to-end operation, then all those systems and assets have to be fallen under the requirements of the trust framework.
Yeah, I think that makes sense. I see another question. Ooh, this one. I like this one. If using certificates with signing authorities, would you have agreements with the authorities with whose certificates they can sign? Then, based on the signature, give appropriate authorization?
So authorization is an interesting aspect because typically certificates are used for identification. The problem with PKI is scalability to authorization because PKI is not agile enough in terms of adding sufficient attributes to the actual certificates to be able to consider them as attributes for authorization or claims as they are using in OAuth. And so for me, certificates could be used to identify an entity as having a minimum set of default authorizations, but you would still translate those through, say, a resource manager in OAuth to a set of default claims then, based on the identity and the origin of identity. And then you would use the authorization system to actually manage their level of authorization on your systems.
I couldn't have said it better myself. Okay, I see another question. And Terrence, I'm not sure on timing. So if we need to stop,
I'm
just
watching the time. You have
okay.
A little more than 5 minutes.
Okay. What are your thoughts on authentication and authorization of the transport, which may traverse multiple networks and infrastructures, wired or wireless?
So if you want to assure the integrity of information, I believe, and you are in a multi-transport, multi-organizational system, my recommendation is to use message signing or information signing, which in a way is equivalent to the use of blockchain, except for the lack of the immutable transaction records that you get with the blockchain. But if you use signing and you use that in transit, then I don't care anymore how many different layers or hops between the original producer and consumer exists, and how many handoffs between service providers, because I know that at the end the message is unaltered. If you use transport layer security, then that's only practical if you do it as an application to application, say TLS or DTLS connection, where you basically know that there's the integrity is only guaranteed between those two endpoints. Anytime that there's a break and inspect, or there is a additional providers in between that may have processed the message, then you're not, you don't have the same assurance. And that's why we did this whole concept of signing and validation as a service with the FAA and Eurocontrol, which is also being used by UPP. Now, of course, when you use signing messages, you better also validate at the reception side that the message signature is still correct. Otherwise, yes, you can accept the message, but you really don't know anything about assurance.
Oh, yeah, for sure. That's an important feature. So I think we have time for one last question. I was going to ask this actually myself, but someone asked this. So what do you foresee are the challenges for integrating zero trust architecture into the UAM environment? And I know there's probably a lot, so maybe stick to the biggest challenge that you see.
The biggest challenge is there is no such thing as a way to federate the observable state of a user or a system, because first of all, zero trust is in that respect still in its infancy and really only works in one organization. And you need to get to a concept of a trust broker that basically could transact that observable state between federated entities, which is a challenge.
All right, very succinct.
So There is one other thing, and throughout the workshop, we'll have a couple more polling questions, but we do finally have a polling question related to identity access management up. If our guests would participate in just choosing one of those, looking at that.
Excellent. Well, I guess, Rob, this was fun, and I guess we'll turn it back over to Terrence. Thank you all for your time.
Thanks, Adam. It was fun for me too.
Interesting. This is interesting. Thanks all.
All right, next up we have Richard Walsh, and he will be talking about blockchain for aviation in UAM.
Hey, everybody. Well, that is an act to follow. My name is Richard Walsh, and I work for CAS, the Convergent Aeronautical Solutions group, and that's within NASA. And what you see here is Wicked Works. It's a what I like to refer to as a kind of an idea incubator, although that does a disservice to, I think, CAS in that it's so limiting. We're looking at issues multiple decades down the road and solving for those. Prior to beginning this presentation, I want to point out that what is to follow is a concept only. NASA is still reviewing our white paper and has yet to determine if this concept is worthy of pursuit as defined. So all of your insight, comments, questions and involvement in this conversation are sought. So we look forward to hearing from you all on this very important topic. We talked a lot about, or a little bit about blockchain, and as you know, blockchain technology is an emergent technology that's finding its way into industry and more specifically into aviation. However, blockchain's introduction into aviation has been largely business focused based on the research that we've been conducting and is yet to be widely explored for aircraft operations. Our CAS-inspired novel approach to resolving advanced air mobility barriers to scale is theorized to be the backbone for blockchain technology's application within the aviation operations domain. It is our contention that blockchain technology will allow for secure peer-to-peer communication in an increasingly autonomous aviation operational environment. To prove our theory, we seek to establish trust, digital trust of information, trust in conveyance of information, and trust in the use of the conveyed information. Next slide, please. Yeah, so I was fortunate in that the Whisk Boeing ConOps was just released as I was preparing for this presentation. And highlighted here are a few of the requirements that revolve around the need for secure data and digital trust. The ConOps recognizes position navigation and timing requirements, or PNT requirements for landing in this case to be in need of development and offers a possible ground-based solution to resolve. It's our contention that the blockchain technology can resolve for these requirements. Next slide. Yeah, so the operational areas of focus is beset by cybersecurity risk, obviously. In the current setting, otherwise useful data is rendered untrustworthy and hence less actionable because of how that information is conveyed. Broadcast in the open, the data is susceptible to external manipulation. Please recall the purpose behind this concept, which is to determine blockchain technology's applicability toward resolving AAM barriers to scale. In conformance with our purpose, we set about to address the question, can blockchain technology allow for secure peer-to-peer communication and in an aviation operational environment? And for that, we must first establish digital trust. Next slide, please. Yeah, here's where it gets good. Our approach is to resolve for trust. Capitalizes upon proven cryptological techniques as indicated by the diagram. In this illustration, position navigation and timing data, data used by an aircraft to map where it is located relative to other aircraft broadcasting their version of the same data that is generated by the aircraft. This is the information that is broadcast in the open, and this is where CASA's unique approach to build trust begins. That data is first encrypted into what we're calling a data token. This token can be transmitted into the open without fear of manipulation due to the inoperability of the cryptography being defeated. Once the token is received and unpacked via proven decryption protocols, that data is now useful to the receiving aircraft toward assessing where it is relative to the other sending aircraft. Next slide. This is kind of our meat and potatoes slide. We propose advancing 3 experiments that we believe will address 2 questions. 1, can tokenization under blockchain enable a new level of security utilizing ADS-B-like data? And 2, can that tokenized data then be used in a time safety critical use case? 3 progressive experiments were conceived to test our thesis. The experiment A seeks to demonstrate the capability for constructing a PNT data token utilizing various data streams. If that's successful, then we seek to determine the token's operational performance, i.e. corruption and or loss of data, latency, and further seeks to determine onboard energy requirements to receive source data, aggregate source data, create, send, and receive a data token. If that's successful, then experiment C seeks to determine the functionality of the PNT data token to enable aerial vehicles to perform self-directed maneuvers to deconflict trajectories. Collectively, the experiment seeks to validate the creation of data tokens, validate the concept through measurement of critical metrics, and validate an aircraft's ability to take corrective action toward deconfliction. Consideration was given to the DVF framework in building out our experiments. That is, the balance between what is desirable with what is technologically feasible and commercially viable. The barriers reflected in the problem space include barrier 1, and I have to have a shout out to Ken, who really kind of did a great summarization of our entire white paper for this. Barrier 1 is enabling a shift to decentralized third-party service providers, and distributed information technologies require a mechanism to enable trust of information products. Barrier 2, increasingly autonomous flight with reduced direct human oversight and situational awareness will increase the dependence on information integrity to ensure acceptance, acceptable outcomes. And barrier 3 is the shift to decentralized third-party providers requires a federated operational concept. And you can see where the blockchain benefits, associated benefits with the barriers are aligned. Next slide, please. Yeah, this is a favorite of mine. Slide 6. While we're focused on the operational use case, we want to illustrate the impact blockchain technology can have in other aviation operational adjacencies. Seen here is a method we believe addresses the automation of regulations. Standards, regulations, orders, procedures, and guidance, collectively the body of knowledge, are central to operating a safe and efficient national airspace system. Therefore, it is necessary to begin with this body of knowledge when assessing a technology's usefulness for the aviation operational environment. This figure illustrates how blockchain can facilitate conformance with the 3 types of regulations used by the FAA. Automation of regulatory requirements will create increased efficiencies for the FAA and throughout the national airspace system. In this figure, automation occurs at the smart contract. In this example, smart contracts are informed by the body of knowledge. Benefits of their use include transparency, autonomy, cost reduction, speed, and automatic updates. When the requirements of the smart contract are met, a token is generated that securely encapsulates relevant data supplied in part by the applicant, the governed entity, as well as data generated by the smart contract as an outgrowth of the applicant meeting all requirements of the contract. I just want to draw your attention to the center of the slide where you see EFARs. EFARs are electronic federal aviation regulations. And between that and the smart contract is an AAM model. I just want to point out that Dr. Nolan, I am paying attention in the MSB model-based systems engineering group that I'm in. So I've been listening, I've been watching. Essentially, it's a model that sits on top of the EFARs that informs the smart contract that generates a token, and it's iterative. Next slide, please. So where are we going? Where are we at in bringing this concept to light? We've completed the concept document and submitted it for review. It's undergoing review currently. Included in our submittal were a series of recommendations we believe will set this concept on the trajectory of the correct exploratory pathway and garner the most involvement from the community of interest. So where we're at now is pretty much that cloud. If you remember the old IBM time clock, that's kind of where we're at. Next slide. So in summary, the blockchain for aviation operations concept defines a process that creates value. That process in cryptocurrency terms may be referred to as proof of location. This type of proof currently does not exist in the wild. In this novel idea or approach, proof of location, parties verify their locations in relation to each other based on spatial and state data. While seemingly similar to proof of work, it differs significantly relative to how parties interact. The prover and verifier, or prover and verifier versus relative authentication, where all parties are both prover and verifier. With that, before we go to questions, I just leave you with one quote, and you get points if you know who said it. No problem can be solved from the same level of consciousness that created it. And I'll leave that as something that if all you guys know what it is, please put it in the, or tell Terrence or me. And that's it.
So looks like we have a few questions here. The first question is, What is the encryption overhead on the ADSB messages?
That's probably a question for Ken, but I would venture to guess that we do not know that as yet. I'm sorry, did I get that? I simply said that I think that's a question for Ken, but I don't believe we know that as yet.
Yeah, so it would be the size of the token. I think that's going to be the overhead.
Okay. Second question is, what are EFARs?
Federal aviation regulations, you can find them on the internet. They're electronic versions of the federal aviation regulations. They're also, and Dr. Nolan can probably speak to this as well if he's still on. They're using them as a core for the model-based systems engineering modeling effort that's undergoing, that NASA's undertaking right now for AAM.
Yeah, there's work on that in the AAM model to incorporate at least the most important ones, let's say. I'm not sure how many they're doing, but the intent is to get, certainly from a proof of concept, to get them in there so that they can then be traced to and referred to.
Next question is proof of location an existing approach, or is that idea something you have developed at NASA? Is there any documentation?
Yeah, so great question. We think that it is new, that it doesn't exist in the wild. It's a term I just recently coined as proof of location. And again, in preparation for this, as I was going through what we've done to date, we keep going back to how do we prove where the vehicle is relative to other vehicles, and it's location, right? Well, this is proof of location. And when we look at how we determine that relative to other forms of, or other proofs, like proof of work or proof of stake, it differs dramatically. So yeah, we think it's a first of its kind.
Next question is, what do you think the computational cost of this may be?
Yeah. Okay.
Yeah, I don't know. I think that would need to be part of the experiment.
Yeah. Yeah, that's experiment 2, where we're looking at latency, energy consumption, and a couple other parameters. Our hope, and this is why we've designed these experiments like we have, is to ask some really fundamental questions that will help us kind of propel this forward.
Guess we're done with questions.
If I could just say one more thing, as the prior group was talking, I was taking some notes. So CAS is about thinking about into the future, what systems are going to need, or what technologies are going to be needed into the future to solve barriers that are going to be encountered. So you have to imagine what those barriers are. And as we were all talking, imagine, if you will, this trusted authentication of an individual. If an aircraft carries with it state data, type certification, tail number, owner, etc. Right? That data is stored as a token that the aircraft carries with it, and it's immutable. When the aircraft wants to gain access to the NAS, a handshake of sorts could occur between the aircraft and the NAS via, say, a flight plan. And as such, the entity establishes trust to use the system. That's but one application of of blockchain within that environment. So I'll just throw that out there. So thank you all for that insight.
Thank you. So next up, we have Ken Freeman, and he will be talking about immutable secure data exchange and storage for UAM.
Okay, next slide. So this is what the 5th or 6th time we've shown this slide. So with the UAM architecture basically moving towards the sort of decentralized environment that with various service providers who are really independent of each other and of the FAA. We're looking at this. This work is looking at a methodology for basically securing the data exchange between those elements as well as the storage associated with it. Next slide. So first thing, blockchain is not cryptocurrency. Blockchain is a technology sort of behind it, like Bitcoin. And it provides, one of the things that it provides is a mutable sort of distributed ledger. Basically, it's a ledger that cannot change. And it's distributed in the sense of my intent with this diagram is that it can be distributed across either within or near certain sort of entities across sort of the airspace structure. And so it can provide sort of this mechanism of maintaining security really without, well, mostly without a central authority. And I'll talk a little bit about the central authority piece of this, but this idea is that you can basically have these distributed aspects, which allows, one of the things that it allows is going to be redundancy across the system. Next slide. So within a blockchain, you basically have this sort of growing list of records, which we call blocks. And there's a cryptographic hash with a timestamp. And sort of by sort of design, once that block is created, it's completely resistant to sort of modification. So basically, once you do that, you have that element. But as sort of new blocks are added, it sort of leverages the hash of the previous block as part of that process. As part of sort of the formulation of that process, and this helps with sort of the complication of changing a block, right? And it just sort of supports that element. Next slide. When we started looking in, and we started, I think, researching blockchain 1.5 ago to 2 years ago, when we were sort of making the decision back then between Ethereum versus something like Hyperledger Fabric. The first decision we had to make, are we going to do a public blockchain or a permission-based blockchain? That's really our first decision. And so a public blockchain is really, it's an open protocol. Really anyone on the network can participate in sort of doing the work to support network consensus. So if you think about what was going on with Bitcoin in particular, maybe 2 years ago, 3 years ago, actually some of this going on now in the sense of people basically using their computers to basically support the calculations to do consensus for blockchain. Permission-based blockchains are, the idea is that it's, well, the transparency is nice. An enterprise, to give some example, I think Walmart is an example using blockchain for its supply chain tracking, those types of things. They're not going to want some other entity outside of that organization to be part of their blockchain. And so what they have is a closed blockchain, it's permission-based blockchain, and it basically, they will do all of the works and all the calculations within their own nodes, limiting the number of nodes from the network. And so we believe anything within a UAM environment, while it is decentralized across multiple entities, we think that those multiple entities would need to be in a permission-based blockchain, and then an entity would make a decision of who participates. And so it would be okay if a SDSP or a PSU are part of the ecosystem, but not your local McDonald's or a university sort of supporting this element as well. I mean, from a compute calculation, supporting the calculations for the blockchain. Next slide. So why? So why are we thinking we should use this? So again, it's a ledger. It's a distributed ledger that we can put our records in. It also can be replicated across multiple areas. And the other aspect is the different participants sort of support the maintenance of the blockchain itself. And so since it's recorded from a append-only perspective, there's a cryptographic technique that's used to sort of guarantee that the transactions have been added to it and modified. And so while it's relatively difficult from a compute perspective to create that problem, the ability to sort of validate that technique is actually relatively simple. And so that's supporting that element. Next slide. So with immutability, this is again the state of not changing, and it really ensures that once you have something in the block that no one can change that. And so with that element, you can have an element of trust within that piece of information that you, as you ensure that since no one can change it. Next slide. Consensus is another element of blockchain, and then if you study what's going on in the blockchain industry or ecosystem that's out there, there's a lot of questions around how consensus is done. There's different ways to do it. But the bottom line is there really has to be a mechanism for once a piece of data is considered correct, is there has to be this mechanism of the elements of the blockchain to basically support and provide consensus that can be added into that network. The research we're working in right now, we're focusing on Hyperledger Fabric, and that uses a proof of work construct for its particular consensus model, but there's other options out there as you go forward. But really, it's a question of how do I make a decision of what I can publish onto a block and what is that method to do that, and that's leverage the consensus. Next slide. So when we look at blockchain from a UAM perspective, I kind of see multiple reasons to use blockchain. And one of some of the things that we've talked about, I think in a couple of the previous talks in terms of identity access management, or identities in particular, is one of the things that blockchain can be used is for providing identity for the pilot or a vertiport service or a person or those types of things. And so we could be using blockchain as part of that entity. And so there's a set of research around distributed identities that's out there that's tied to this kind of work that's going on. Another aspect, and this is actually used in, I think, in various industries, is this idea of payment and settlement. So charges related to, say, a decentralized environment, maybe leveraging any financial elements, all of that work from basically that side of the house could be done within a blockchain as well. And it could be a distributed system that could work across multiple ecosystems. Third question is provenance. Basically, in order for business transaction, it's really making sure that there's again, that's really understanding the data is true that you have in there, and that can support things in case there's sort of a need to sort of look at that information basically after some type of conflict or near miss or accident or those types of things. And then the last one is data tracking, and this is the one that I see in industry the most, particularly around the tracking of sort of products in industry and tracking that. We think that applies to UAM in terms of it can help with tracking of flight scheduling, flight intent, resources within the vertiport, licensing, and those types of things. And we'll talk about some of that a little bit later in this presentation. Next slide. So this is sort of the threat slide that I had sort of shown earlier of basically some of the types of threats that we see that could happen to within a UAM environment. So if you go to the next slide, we'll kind of show that blockchain doesn't solve all these problems, but it does. We do see that it can participate in some of those areas. So next slide. And things like a man-in-the-middle attack, particularly data manipulation, I mean, it's perfect for that. Things like if you basically fall to phishing, which could lead to sort of interaction with malicious content, and particularly exploitation of sort of valid accounts, really leading to the loss of credentials, those types of things, as well as things around access to valid accounts or access to sort of public-facing systems, and making sure that the data is not encrypted because it's basically protected by the blockchain, or the blockchain's immutability. So next slide. I want to give an example. I'm going to talk about kind of a specific issue. So there's a couple of computer science problems. I'm going to focus on the simpler one. It's called the two generals problem, and kind of talk about how blockchain supports this, and then I'm going to apply this to, it's one of the use cases that I think Annie and I have been talking about. And so just kind of imagine that you sort of have two armies with you have an army with basically two different generals, or two basically sort of sets of troops, and the intent is basically to attack basically a city. But each of them are sitting in a valley, so they can't see each other. And there's this third target that they're basically trying to get to, right? And so the idea is, since they're in the valleys, they can't see each other, so they would have to send messengers back and forth for communications with the risk of being captured. Next slide. So think about this, where the first army says we're going to attack at dawn, but they need both armies to attack at the same time, and they send out a messenger, but you don't actually know that the messenger would get there, so you're not sure if the acknowledgement would be received. And so this process could go back and forth, where these two basically different armies can keep sending messages, but you never know if the messenger is captured. If you're the army on the other side, you don't know who the messenger is going to be. And so there's a lot of different sort of concerns in terms of understanding the elements of whether or not that's the actual message that you're getting, and there's not this way of acknowledging it. I want to give this analogy. So go to the next slide, and then sort of apply this to sort of UAM. So kind of similar. So if I'm in a UAM environment and I basically have two UAM operators who have intent, and so they've planned flights and they're trying to get to the same vertiport. So kind of imagine this sort of similar idea. So let's say from a pre-flight perspective, the UAM operator, let's pick the green one, they need to send their flight intent to their PSU, and then that will need to go to, let's say, to the DSS to help with the resolution, or if it's an FAA controlled airspace, that intent needs to go out to the FAA as well. So the question is, what happens if we lose any aspect of this from a data integrity perspective, or loss of services, or a spoofing perspective? The question is, what do we do about this if we have that risk of losing these ideas? So I can lose either PSU, I can lose access to the DSS, or I could even not even lose it. I could just have data corrupted in transit, or data basically lost from those elements, right? And so what we're thinking is, we think we have, one of the things we're looking at right now is sort of researching this from a blockchain perspective as we go forward. So go ahead and go to the next slide. So we think that the idea is that the blockchain really embraces that sort of peer-to-peer decentralized design that could basically takes away from that central authority. So the idea now is that each of those operators would basically pass their information through the PSU, and it would basically reside on the blockchain element. And so maybe we would put that forward with flight intent, and then the operational elements of the blockchain would replicate that across the blockchain. And before the next PSU tries to basically make its intent to understand of where the flight is, they would actually be checking that blockchain, which through the blockchain technology would basically apply a consistent messages across the chain. So we don't have to worry about losing the messenger. We basically would have that sort of the construct and the proof of work and the consensus elements of the blockchain supporting that work as we go forward. So it's really good art. We think it's a good approach from a research perspective, for particularly in the cases where parties do not trust each other, and really not trusting each other really from the perspective of, we really will not know what's happening in these different service organizations. But at least we can have a common set of sort of information that we're sort of relying on as we're making decisions. I think that's my last slide. Next slide. Back to you, Ted.
We have a poll here. To what extent is your organization currently using blockchain technology? We can show the results after the questions. The first question is, how would you federate different blockchains?
Okay, so federation between, and I'm going to go back to a question that Danny was asked earlier in the day. So if I have multiple blockchains, so for example, if I had, and I imagine it works like this, it may not be correct, but if you have a UAM environment, and I live in the Bay Area, let's say it's in the Bay Area, and I have a different UAM environment. In California, we have this city to the east called Sacramento. Let's suppose those are operating on different UAM environments and different blockchains. It's actually an active area of research in terms of trying to figure out how to interface between those blockchains. It's actually an open research question in the blockchain community. There's a lot of, I would say at the moment, I'm not aware of a good solution. So I think there's salespeople trying to tell us their solutions, but I don't know that it's a good solution to that at this point. But that is definitely an active area of research of how I would go between, I mean, we've chose Hyperledger Fabric, there's Corda, there's Ethereum, and so there's all of these different blockchains, but it would probably take a piece of software in the middle between those to support those interactions, and they may be independent based on the way those are built.
Okay. The second question is the blockchain acting as the trusted central authority?
So when the use case we're thinking about at the moment is if vehicles are flying and they have to rely on some function for understanding operational intent and sort of trusting that function, we do see the blockchain as a trusted function, but it's decentralized because it is the element of the blockchain network that you communicate may not be the same location for everybody. So it's decentralized, but we are seeing it as a trusted entity.
Another question, is blockchain verification in series sequence? What if there is a failed block?
I think the answer to that is really blockchain approach specifics, but I think with the Hyperledger Fabric that we're working on, I think the verifications are done in series. That's my understanding. And so in the case of Hyperledger Fabric, there is a sort of centralized, what they call ordering service, which makes the decisions as information, so that there's two sides. There's the intent to sort of add something to the blockchain is one side of that, and the other side of it is to read the blockchain. And there is something in the middle that basically makes the decisions of the order that those go in. So but that is done in series. If there is a failed block, so I think a failed block would be if you try to add to the blockchain and the consensus doesn't come through, then that would just simply not be added to the blockchain. I think that answers that question.
Another question here. How do you deal with finality and consensus speeds, which make the majority of DLTs unsuitable for aviation?
So I would say blockchain is unsuitable for detect and avoid use cases because of the time for it to come to consensus. I am one of the work we've done in the past, we are questioning, is it even suitable for collecting telemetry directly? We think it is at UML2, but we're questioning once we get to UML4 if it's the right solution for that. But we think everything else, flight intent, things that can support regulations, things that can support identity management, things that support provenance. We do think blockchain can fit for those use cases, but anything that would require very quick consensus, and when I say quick, things less than a second, or not less than a second, but less, getting into the milliseconds, we think blockchain is not the right solution. Things that are into the 100 milliseconds, if you can make the decision in that time frame, then we think blockchain is viable for that. And that's why we think it really fits for the intent, operational intent, and those types of things.
There are no more questions. We will now show the polling results. We're going to be starting our next break now. It's going to be roughly 20 minutes, so we shall continue at 12:30 p.m. Pacific time.